Let me share screen. Okay. So this is class 2 of Python programming presented by Gavin Peng and Amin Bot. So for the agenda today, first thing we're going to do is we're going to go through the overview of concepts, which is the basics. I understand last class it was pretty confusing. This time we're going to try to be more concise and better understand the topics at hand. Second, we're going to look at a new function, which is the input function, which you can take input from the user. Next, we're going to go through module, the math module specifically, and we're just going to look how we can use Python to do math and just a general overview of the math module that you can use. And finally, we're going to go to conditionals, where we're going to analyze if, elif, and else statements. Okay. So the first thing I want to do today is go back and review string slicing. I understand that we did this last time, but I also understand that not all of you fully understood it. So I just want to quickly go through this for the first little part of class. So I'm going to go to my Google Colab. Oh, by the way, guys, if you just joined, or feel free to pull up Google Colab and copy down what I'm doing. It helps build in coding knowledge and just strengthens your coding altogether. Okay. So what I want to start out today is on a quick refresher where every character in a string has a position number starting at 0. Okay, so every single character. So you guys remember variables, right? If I create a variable called word and set to be equal to the string Python, okay, since every character inside the string has a position that starts from 0, if it starts from 0, then the position of the character P will be at position 0, in which, thus, if I print out word, square brackets, position 0, I will get, sorry, it takes a little long. I should get the character P, which is right here. So starting from position 0, which is the character P, Y will be position 1, T will be position 2, H will be position 3, O position 4, and N position 5. So if I print word, square brackets, 5, then I will get N. Okay. So hopefully that makes sense. Okay, next, we're going to quickly go through string slicing. A slice is in this type of format. So it will be this format, which it will be start and then stop, which it grabs everything from the start up to the stop, but not including the stop. So if we do the same thing, we create a variable called word, set it to be equal to the string Python, and then we print word. So if we wanted to have the output be equal to the word pyth, like Pyth, then we would go from position 0 to position 1, 2, 3, and 4. And because the latter part, the stop, is exclusive, that just means that it will not be included in the output, in which the output will just be Pyth. So since start is inclusive, we will start from 0, and after the colon, it's going to be the stop. So we're going to stop at 1, 2, 3, 4, which 4 is the position, or 4 is the position of O. So if we want to output Pyth, this is what we will output. Okay. Does that all make sense? Okay. I'm just gonna assume that makes sense. If you guys have any questions, feel free to ask the chat. But yeah, I'm just gonna keep going on then. Okay. So now we're gonna include the step argument where I'm gonna make a new, so oh, whatever. Okay, whatever. Okay. We're gonna introduce the step argument where it's gonna be essentially this start, stop, step. Okay. So if we set word to be equal to the string Python, and then we print word, and we do 0 to, let's see where the ending is. 1, 2, 3, 4, 5. So it's gonna be 6. And then step, how much we want to step by, let's say 2. So it's just gonna go over every other character. PTO. So it's gonna take P, take T, and then take O. Do you guys understand that? Because 0 is the starting character. The start is inclusive. So it takes the starting character and we just keep going, keep going, keep going until we stop at the position 6, which is exclusive, which is the entire string. And then how much we step by is the step argument, which it's P, skip 1, T, skip 1, O. So, and the output is PTO. All right. Hopefully that makes sense. Um, if you guys have any questions, just ask. Okay. Well, okay. Now, okay. So right here, initial index inclusive step, and final index is exclusive. So let's go through some examples here where the text is equal to Python, then the text from position 2, in which if the arguments are empty, then the default positions will be stop will be to the end, and the step will be 1. And if the start is empty, it will assume the default argument, which will just be the very beginning. So if it starts at position 2, we know that the initial index is inclusive. So this is position 2, which is T. And then if you assume the default because these arguments are empty, it will just be THON because it will be 1 for the step. Um, for this example, because the start is empty, we assume that just starts at 0, right? It just goes to PYTHON, or it just goes through the entire text until it stops, which is at position 4, which is exclusive. So it goes 0, 1, 2, 3. So it's going to be output piped. Step is default, so it's just going to be equal to 1. Now is our final example, which is a step of 2. Since stop and start are all default, we can assume that it starts at P, ends at N, and we'll just skip until it ends. So the output is PTO. Okay. Okay. Um, I see a lot of people are joining like now. Um, Hi guys. We kind of just went through last class, which was string slicing for like the first like how long? First 15 minutes. So, if you guys are unfamiliar, feel free to ask questions. But for everyone who just joined, we plan on going through the math module and the input function for today. We just kind of went through like a review of string slicing. Okay. Okay. So let's talk a little bit about the input function. Um, yeah, everyone is a little bit late. Okay. Oops. I'm lost. Okay. 1 second, guys. Sorry. Okay. So, okay. Let's go through the input function. So basically what the input function is we set a variable to be input to some text. And then the text that you write in, basically it will ask you the input. So, okay, I think it's better to show and not tell. So what I'm going to do is I'm going to show you guys. Okay. Let's say we set a variable to name. Okay. We set it equal to the input. What's your name? Think of input as like asking a question and then you, the person, are answering. So it asks me, what's my name? If I say Gavin, the name Gavin will be stored into the name. So if you ever ask what the name is in the future, the name, if you print the name, it will be equal to Gavin. So let's test this out. If it asks me, what's my name? And I print the variable name, if I say my name is Gavin, if I print name, the name is going to be equal to Gavin. Does that make sense? Um, yeah, basically. It just asks you. It's not necessarily like Gavin. Like, for example, if I type in like Ottman, now the name has it's stored as Ottman. It just saves your name, like depending on what you're typing. Um, and you can do some cool stuff with it, like you can do hello plus name. So if I type in my name, let's say my name is Ethan. Hello, Ethan. Um, yeah. So at the start, this is just the prompt. This line of text is just the prompt. The code would work the same way if there wasn't any prompt. This is just help, like, it asks the question. So if I deleted this text, this would still work, but it would just be empty. So if I said Gavin, it would output hello, Gavin. Hopefully that makes sense. So inside of the parentheses is the prompt for the string and the text. Okay. Well, I'm gonna assume that we can move on. Um, okay. So yeah, where the type response gets stored, the program can use it later. Um, it's always it's always input parentheses. And yeah, the inside of the parentheses is considered the prompt text. Okay. Oh, and yeah, this explains it a lot better than I can. The prompt text is just an optional message shown to the user right before they type. So it's optional, meaning you don't necessarily need it. Um, okay. Okay, this is important. Um, the input function always returns a string. So even if the person types a number, Python will store it as a text. Okay. So for example, if hypothetically I set a variable called age equal to 1, and if I printed age plus 1, the output would be 2. Okay. Now, if I had age equals input, what your age, and then, oh, well, sorry, trying to finish the program. Print age plus 1, and then what is my age? If I say 1, there will be a type error, meaning that the age is in string format when we need to change it to an integer. To get around this, we can just simply just change it to an integer. But yeah, so basically this function basically just changes the variable, the variable's data type. Um, okay. Oh yeah, and if we want to try to use the type function that we learned from last class, try doing that. Just for a refresher, the type function is used to check the data type of a variable. So what is your age? And then this is a class of string. Okay, we're moving on. Um, okay. I guess I kind of did this, but if we want to typecast, say we don't want string, it's totally we're totally able to do this by typecasting it. So typecasting is basically just converting the string data type into an integer or float or whatever, right? So as we learned from last class, it converts the integer data type is basically a whole number. And it can be 1, it can be 0, it can be negative, it can be anything just as long as there's no decimal points. The float is a decimal number where it can be like 1.99, 1.2, and it can also be like an integer. It can be a whole number. Um, but so we're going to try to typecast now. So if we have, let's say, oh, we can use this, I guess. If we have, what is your age? But then we typecast this because this is a string data type. So we can typecast it into an integer. What is your age? If we turn it into an integer, then the output of this age will be an integer. So if we try to print age, it's not going to work. Oh, well, okay. If we try to type age plus like 1, it's not going to work. Oh, well, okay. That's okay. But basically, all it does is just typecast this string into an integer. Um, yeah, like basically, if say this was an integer, and if you type age plus like 1, it's not gonna work. Yeah, it's gonna be type error. So hopefully that makes sense. Okay. Um, does this all make sense? Because I'm not sure. Like, I need some like validation if this all makes sense. Okay. Okay. Do you want to do this? You know what? Yeah, we can. Okay.
Okay, so using everything that we learned so far, I'm going to show you guys a live demo of a two-number calculator. Obviously, there are going to be some holes in this calculator, but that's there's more information ahead as to how to refine it. But for now, we're going to create a simple calculator. So,
Yeah.
okay. Let me know if you guys can see my screen.
Oh, you okay. That sounds fine.
Okay, so obviously, with a two-number calculator, we're going to need two numbers. So let's first have number one. And this is obviously operates off of user input. So we're gonna have user input. But we need to make sure, like Gavin said, for user input, it always returns a string. So we want to typecast this into a float, right? So we can account for the integers and the decimal numbers as well. So as usual, we're gonna have our user input, and it could say enter your first number. But then we also have to typecast this into a float. So it's actually a valid number that we can use to perform operations on. We will also repeat this process for the second number. Say, enter your second number. And for this calculator, just for time's sake, we're gonna only gonna have an addition option. So now we have our two numbers, user input, number one and number two. Now we want to add them together. So we can declare a third variable called sum, and that'll just be the sum of the two numbers that our user chooses. And just like that, you could go ahead and, well, obviously first, and then after that, we're going to print out the sum. Okay. Or, yeah, you know what, we're just going to print out the sum. So the first number, let's say we want to choose 5. Our second number, we can do 5 again. So the sum is going to be 10. And notice how that because we use the float as our number, it always is going to show like this little like extra decimal point right over here. But otherwise it's still an integer. We can do another example or like another set of numbers. We could do some negative numbers. Like we could do -4 and -10. Adding these together, we're going to get -14. So kind of like this with user input, you're able to kind of, I guess, add a little bit of your addition to the code. But for that, yeah, that's just a simple calculator. You can do other operations as well. Like you could do a subtraction. Obviously, that wouldn't become so that'd be a difference. But in that way, like you could also do that. So for example, 7, 5. Oh, sorry. Gotta print out the difference. 7, 5. and then 2. So like that, you can do a whole bunch of other operations. You can multiply, which is with the symbol. You can divide, stuff like that. But just note that when you divide, it will show an error message if you because obviously you can't divide by 0. So
Oh.
if you want to print out a quotient this time, let's just observe what it um outputs if we have 0 as our number to our denominator. So we can choose any number here, and if we do 0, obviously we get an error. It's zero division. It's actually called zero division error, and because we divided by 0, so we can't do that. But you can do a whole bunch of different operations. But that's our simple two-number calculator using user input and typecasting.
Okay. Okay, I'm gonna share screen. Okay. Okay, so you guys understand that, oh, not this. So I'm assuming you guys understand by now that um basically the variable just saves the input, and this is just the optional question that you can ask to get the input. It's kind of like a guideline. And yeah, it's just a pretty simple calculator that you can make. So it's combining all the skills that we've learned so far, including input, typecasting, and some math. All right. Yeah, it's pretty awesome sauce. All right. Now we got to talk about modules, where a module is basically, hold up, I Zoom is like being weird. 1 second. Okay. A module is a file of pre-written Python code where it's basically just like, it's like a self-contained like chunk of code within like a file or a package that like does one job and then be plugged into a bigger program. You guys don't really need to like understand like what this is. Like understanding this doesn't really matter. You guys just gotta know like what a module is. I guess like ignore the right side. It looks kind of confusing. But modules contain functions, values, and tools that groups of people have already built and tested. So one such module is the math module, where you, at the top of your Python file, you just write import math. And you can just use the built-in functions within the math module. So I think I'm going to try to show a demonstration. If I just do import math, this is the math module where it has built-in functions. And oh, okay. If you just do print math dot square root of 4, everyone knows that the square root of 4 is 2. So if you didn't import this module, Python doesn't understand what this is. As you can see, there's like a yellow thing, but it still works because Google Colab has like built-in modules. But like usually you need to like import the module at the top. So um yeah. Okay. Okay, I got a question. If we're gonna have homework, like we're gonna have homework, but like usually the homework is like super easy. You just like knock it out in like 5, 10 minutes. Well, at least hopefully it shouldn't be too hard. If you guys have like questions on the homework, like you can ask. But yeah, we're willing to like stay after class if you guys need help on homework or anything. Okay, I saw someone just joined. I don't know if I want like totally review. Okay. I think we'll just go on for now. Okay. So this is us importing the math module. Import math. We set a variable that's named result to math, a square root of 25. Everyone knows that the square root of 25 is 5. So once we print the result, the output 5. Okay. These are some useful functions in the math module. Feel free to look. Um, I guess it's probably best to like show like the math module. So okay. So like let's first start out by importing the math module. So import math. And then let's do print math dot square root of like say -4. Does anyone know like why this isn't possible? Oh wait, okay. Like not necessarily the period, but like the -4, I guess. Like just square root -4. Like well, it's not possible because in math, there's not really any two numbers without, I guess, imaginary numbers that can equal -4. Um, yeah. Okay. Okay, so just go down the line of doing some demonstrations, I guess. So we know about the square root function, which this will be 12. If we do, yeah, yeah. If we do math dot, like, okay, so math dot seal, it's like rounding up. So if we have like the number like 7.9, if we have math dot seal, this will round up the number. So it's going to be 8. Now on the opposite side, if we have math dot floor, 7.9, um, it's basically just gonna be 7. If we have, I don't know, let's say math dot factorial. Let's say math dot factorial 3. So a factorial, I don't know if like everyone knows it. Okay. Miranda said she can't get into the classroom. Um, Ethan, if you're online, can you please help her get into the classroom and go into a breakout room? I don't know if he's online right now.
I could
Miranda,
help with that.
yeah. Okay. I guess like Miranda, if you still have like questions after like class ends, like you can stick around a little bit and we'll try to help you get into the classroom. I'm assuming you can just like click a link. So, man, if you have like the Google Classroom link, like you please like send it to her.
Yeah, I'll send her.
Okay. So you guys don't know in math, the factorial is just the number times the number minus one, I guess. So factorial is gonna be like 3 times 2 times 1. This is the factorial of 3. The factorial of 4 is 4 times 3 times 2 times 1. So the factorial math.factorial 3, it's going to be 6 because 3 times 2 is equal to 6. And we all know that 6 times 1 is equal to 6. Any number times 1 is the number. Um, okay. I think another fun one could be, I don't know if you guys know this, but this math, but if we do math dot hypotenuse, hypot of 3, 4, is hopefully it's gonna output 5. Um, okay. So we all know that if we do squared, like let's set a variable, let's set it equal to 2 to the power of 2, print squared. That's going to be equal to 4 because these two asterisks indicate to the power 2. So if we say 2 to the power of 3, it's going to be 8 because 2 to the power of 3 is equal to 8, as we all know. In the math module, we have something different where we can just do maths dot, I think it's pow 2, 3, and it's 8. So I guess it's just like a different way to do it. I guess it's just preference. Um, see what else I can do. Okay, well, so okay. I don't know if we have a slide for it, but we're also planning to do conditionals. So, hmm, okay, I think we're gonna spend like I know a lot of people miss the input section. I think I'm just gonna go quickly go over input one more time, do some more like advanced input stuff, and then go from there. I think that sounds like fine. And then we do like conditionals so that people that heard the input section can learn it, like more of it. Um, yeah. Uh, okay. So let's do firstly, let's do so the input function, it's a function where if you set a variable to it, let's say let's do price is equal to input. Um, let's say what is the price of this? Question mark. So basically the input, this is the question. It will print out a string of this, and then it will send, it will ask us this. You see, there's a little box right here for Google Colab, which is very nice of them. We answer if we say the price of this is 15.15. This is what price will be equal to. So let's print price. And then 15 will be the the output. And then if we do, we can typecast this. So typecasting is changing the data type to a different data type. So if we typecast, because currently this is a string, if we typecast this to like float, like a floating point number, then it's just, it's going to make it so that we can add to it, like essentially. So before, since this was a string, if we do this price, like +1, we're trying to add 1 to a string, which just isn't possible because that gives us a type error. If we instead typecast it to an integer, we say 1, we're able to print out 2. I guess that's the very basics of it. Um, what Ottman showed was he showed a simple like calculator program that we can make with it, which is like super simple. We can make it in like 3 lines. So if I set like a equals to integer, input first number, basically this input will go into a, and then set b equals to integer, input second number, you print a plus b. If we set first number, let's say 5, second number 4, it's none. So that's just a quick review of um, the input function. Okay. So I think Amin wants to show you guys some fun stuff with the random module. Maybe after the showcase, you guys can play around with the input, and then we're gonna quickly go to conditionals.
Sounds like a plan. Um, so let me just set it up. So obviously there are a lot more modules than just the math one. So there's also this fun one. It's called the random module. And what it does is by definition, it generates pseudo random numbers. All you have to know, it just generates random stuff, as suggested by the name. So if we can import the random, I don't know if Google Colab has it built into here, but better safe than sorry. So what we can do is there is there's one I guess function. It's called random.random. By default, what this one does, it's gonna choose a random floating point number between 0 and 1. I think it's inclusive. So if we were to just print this out, it's gonna take a while, but it will just generate a random number between that range. Um, Come on, go faster. I have to refresh it.
It's pretty slow.
I got, yeah, let's see what it generates.
Hopefully it works.
I tested it out. I thought it
It's
would work.
taking it's taking a
But
little bit of time.
I guess for this function, or for this function, what it does is going to generate a random floating point number between 0 and 1, inclusive. There's another one. It's called random integer. And this one you can
Brilliant.
choose your range. So this is the general like structure of it. So for this one, like what it does is for this function, it's just gonna be like it will print out a random integer that's between A and B. So I can replace A and B with anything. So let's say I wanted a random number between 1 and 100, then it will usually print it out. I don't know why it's not working right now, but
Yeah.
that's basically so like with this you can kind of create like fun I guess fun games. It's fun to play around with as well. But yeah, that's like things like a quick run through of like the random module. You can also like we're gonna talk about this later on in the course, but you can select random items from lists and you can also shuffle lists, but you guys probably don't know what that is, so we're gonna go into that later in the course, but just to let you know, that's the random module.
Yeah. Okay. I'm thinking of giving you guys like 10 minutes just to take in everything you learned, like, and play around with. I'm expecting you guys to like play around with it in Google Colab. Um, so to recap what we learned what modules are. We talked through the math module, which namely can just do all things math. It has factorials, it has square roots, it has the dot roof, dot floor function. Um, I know that like what we typed out, you don't like remember it like instantly. So if you guys want to search up specifically functions in math module Python just to play around with it, that's good. Our functions in random module Python. We also learned the input function where you take in, okay, you take in text from the user and you can just do stuff with the text. So yeah, I think Amin has something to say. Um,
If you guys want to like, uh, you know, you can search it up online if you want, like all the math functions in the module. Or what you could also do is you could also run a command. I'm gonna just show you guys quickly. It's similar. So I don't know if you guys remember from last class, but we learned about string methods. And the thing about string methods is that there's a lot of things you could do with it. So Python was the language was nice enough to I gotta open Google but the module was or Python was nice enough. I just lost my train of thought. I'll show you guys. Oh yeah, they were helpful enough to make a help string function where you can see all of the different kinds of string methods. I think I showed you guys that. I don't even think it's gonna run on here, but I'll just show you guys the command. It will show you guys all the math functions that are part of the math module. All you gotta do is write this function, help, and in parentheses math. If you if you print it out, it should show you all of the different math functions with brief explanations. If you guys want to get a quick list of all the functions, you can also put in this one. Uh, I guess, yeah, dir math. It'll give you just basically like a list of all the functions, but that should help you like maybe, fall back on some of the functions if you want to know them.
yeah, so we learned string methods, string slicing, quickly recap that today, and then we learned input. So um yeah, we're just gonna take I think 8 minutes probably, and then go into conditionals maybe. I don't know. I think that sounds good. Just like feel free to play around because I know like the stuff we write down, like when we lecture, it's probably like pretty hard to remember. Okay. No, class isn't done. So we're stopping right now just to give you guys some work time to like play around with the stuff you guys learned, which is the input function. I guess here I'll share screens just so that you guys can like see. But class ends at 4:30. We're planning on going into conditionals afterward. I don't know if we're gonna need tomorrow to fully go through conditionals though, or not tomorrow, next time. But yeah, we're just gonna give you guys some time to like play around with it. Because I know that like just watching lectures and not typing it out is gonna be like super hard to like remember. Um, yeah. So this is the input. Maybe play around with it. Try to make a calculator of your own, and we'll be back like super soon. Okay, so I got a question where we can see the recordings. All of the recordings are uploaded to the Met Excellence YouTube channel. Usually we send out an announcement in the Google Classroom. The Google Classroom has a ton of useful stuff. Like It has all the recordings. It has homework. I think it also has like some extra work maybe. So if you guys need like extra help, check the Google Classroom or like stay around after class. So yeah. Okay, so we're gonna start like in like about like 1 minute or two, but I got a question that those green hashtag headers aren't needed, and you're 100 or sorry, you're 100% right. Um, these like aren't needed. They're called comments. Like you just use them to tell what is under it. So, for example, I spent a bit of time playing around, making 4 different calculators. And this one's called the addition calculator. The hashtag, it just doesn't include the code. Like if I was to type like this wouldn't be proper code, so you need a hashtag. Yeah, yeah, essentially. Okay. This will take like 1 or 2 more minutes, and then if you guys like are confused on what to do, I just like you can copy me. It's always good to build like muscle memory for typing the functions, I guess. Um,
All right, it's 4:05 now, so I think we're gonna move on. Um, so maybe finish up whatever you're doing, and we're gonna go on and learn about conditionals and just like very surface level knowledge on what conditional statements are. So just as like a precursor to whatever demos I do, um, an if statement is basically is just this. If something happens or if this happens, then that will also happen. So let me show you what I mean by that. Yeah, I'm gonna share my screen now. So let's just say we have some scenario. Let's say we want to verify someone's age. Um, so for anything. So let's just do age and let's just make this like a user input problem and kind of just like apply the knowledge that we've learned. Just ask them for their age. Oh, enter your age. After that, we're gonna have an integer output. So first thing we're gonna go through is what an if statement is. So like I said, if something happens, then something like a subsequent action will happen. So let's say the age is less than 0, for example. So this is usually like the format. Let me show you what the format is. So the format is usually if and like whatever statement you have. You're gonna put a colon here, and then after that you return whatever you want. In our case, what we're learning, we're just gonna be printing something in return. So in our case, if age is less than 0, then then what will happen? Well, if the age is less than 0, then you know, let's just print invalid input because no one can be less than 0 years old. So let's go ahead and test this out, right? See, if the age is, let's say 7, or actually, wait, that wouldn't really work, but let's just say you're -1 years old, then it would say invalid input. So that's when we move on to adding additional if statements. So once you have one if statement already written out, all the statements after that they're going to be called elif statements. Elif is short for else if. So you guys can probably see else if. Uh, so yeah, that's like a shorthand way to write else if. So for all statements after if, elif are just your other cases, right? Just make sure that after your first if statement, never write another if, write an elif. So let's say our elif is if age is um greater than 100, for example. If your age is greater than 100, then let's just say you are way too old. So that's our second case. And so we can go ahead and test this out. So obviously we have nothing in between 0 and 100, so let's just test out like 101. And it would say you're too old. So let's go ahead and put in our else statement. So what an else statement is, so obviously we have the if and the elifs. Those set like actually like genuine parameters or genuine cases, right? So like first our case is age is less than 0. Our second case is age greater than 0. So if you want to address all the other cases, then we use an else statement. It just essentially just accounts for everything else that you missed. So let's say else, and the else statement is going to be perfect, right? There's nothing wrong with their age. So let's say now you're 5 years old, then you're perfect. And then let's say you're 105 or you're way too old. So in that way, that's basically like a surface level kind of overview of if, elif, and else statements. But then there's one really important thing you have to understand, and that's the order of your statements, right? So let's say let's say we have some case, right? Let's say we want to say if age is less than 13, right? Then we're gonna say uh you are less than, or let's just say like perfect, right? Perfect. If we have another conditional statement after that, but let's say this one is, or actually, wait a second. Let's do this one less than 100. Or hmm, what could a possible case for this be? Oh yeah. Let's say over 100's a case, and let's say over 13's a case, right? And just pay attention to the order of this. So obviously if you're over 100, you're too old. If you're over 13, let's just say you're perfect. But I want you to pay attention to this, right? Because with if and like with conditional statements, your code is always going to be scanned from top to bottom. So when you run your code, Python's going to be like, okay, let's read this statement first. Okay, if that statement doesn't apply, then let's move on to this next statement. So for here, let's say we have someone that's 14 years old, right? Well, theoretically, they should be perfect because they're not over 100, so they're not too old. So let's test it out. Oh, wait, my code is just, it's not running. Gavin, could you help back me up here? My code's not running.
Yeah, okay. It should be perfect, but it is a little slow. Okay. I guess I'll share screen. I'll take over for now, but okay. Okay. So what you guys learned from Amin is that you just learned the basic if, and else. Say x equals 10 if x is greater than 0, print positive. Actually, this would be better if it was an input. By the way, for inputs, it looks a lot cleaner if you put a space between what you're at, between your string and the outside, I guess. It looks a lot cleaner if you just put a space at the end. So that's what I'm doing. And okay. So essentially what the if statement is, I know Amin talked about this, or he just did, I guess, rather. But it just asks if this thing occurs. So if x is greater than 0, then we print positive. We all know that numbers greater than 0 are considered positive numbers. So yeah, so what we do is if the input we give to x is greater than 0, it's a positive number. We can say else if, which is elif in Python, else if x smaller than 0, you print negative. Oh, well, okay. So another thing that should be noted is that we use a colon between this and the next line. And you can see that after the if statement, the next line is a bit indented. The indent shows that this line is under the if statement. So if this occurs, then this will happen. This else if statement is not indented under this if statement. Um, so it is not within the if statement's bounds. So this means that essentially it's just not in the code of the if statement. If this happens, this won't run through, I guess. If that makes any sense at all. Um, okay. Okay. So I want to quickly refresh a little bit. I kind of explained it a little bit, but I want to go to what Ottman was talking about earlier. He had something that looked a little bit like this. He had an age variable set to the input. How old are you? And he had if age was greater than 13, print teenager. If age greater than 100, print old. Okay, so if the user puts in, my God, this thing a lot to run. Okay, the user puts in, let's say 14. They're a teenager. Um, However, if we say if we want it to output old, we're gonna need to input one like something above 100, right? So let's say 101. If we input 101, the order really matters here because it's gonna output teenager. The reason why it outputs teenager is because the code goes through, it sees that what the age is greater than 13. So because of that, we need to print teenager because that's the first thing we see. A with age greater than 100 is the second thing that the code sees. I mean, if you have any comments, you can
Yeah, that's what I
later.
was gonna say. That's perfect.
Yeah. So I guess a better way of doing this would be like 20, I guess. So between like, oh wait, this is really bad. Sorry. Okay. So sorry if this doesn't like make a ton of sense. I don't know if we went through this. I think we might have a little bit, but basically this greater equal sign shows like you guys have done math. You guys know what greater and equals does. This just shows which side is bigger. So and then the equal side after it, it means um like greater or equal to, like in this case, like equal to, like like the sign with the line on the bottom. Here, let me try to annotate. This is basically what the code is saying. It's just the greater or equal to sign, or the smaller or equal to sign, rather. So if 13 is smaller or equal to age, which is smaller or equal to 19, then it will print the statement that you are a teenager. So if you are, let's say you're 13 years old, sorry, if you're 13 years old, then you're a teenager. If you're 100 years or 101 years old, I guess, you're old. However, currently, if you type in the age like negative something to 13 or 19 to 100 or 100, like, or 19 to 100, what you get is like if I type in like 67, like you just get nothing, right? So that's why we need an else. Else print. So if we type in like what, 56, we're gonna get the output not teenager or old. Okay, so that's just the basics of it, right? Let's make a new file or a new cell. Um, so we're gonna So there are four ice. There's like six. So six comparison operators that we're going to be using. Now, these comparison operators, this is one of the few comparison operators. It's just showing the comparison between the two things you are comparing, if that makes sense. We have the smaller sign, the greater sign, smaller equal, greater equal. And then if you want to say what, like not equal, it's this. And you would think that the equal sign would just be this, but in Python, it's a little weird. It's a double equal sign. Okay. So I want to do, I guess let's try, hmm, okay. Okay. I'm going to type a program that shows whether the number we input is positive or even. Shoot, wait, I don't know. What should I do? Okay, but that essentially these are the comparison operators that you will basically always see. Uh, so I guess I said we're gonna do an even and odd, even or odd program. So if we do x equals to integer input, enter a number if x. So this is something you might not know necessarily, but I think we did cover this. But I guess for a little refresher, if x mod 2 equals 0. So there's a couple things to look out in this statement. Notice the percent sign. This is a little weird. Essentially, this just asks for the remainder. So 11% 2, the remainder, it's going to be 11 divided by 2, and then it's asking for the remainder of 11 divided by 2. So this is going to be equal to 1. 10 mod 2 is going to be equal to 0 because 10 divided by 2 is equal to 5, which is a whole number, meaning no remainder. That makes sense, hopefully. Oh, and another thing, if this equals, so double equal sign, as shown here, which is our comparison operator here, is equal to 0, and then colon. Um, print the number is even, else print odd. So you guys see how this works, right? All even numbers, when divided by two, it becomes a whole number. So 2 divided by 2, 1. 4 divided by 2, 2. Every even number divided by 2 is a whole number. Every odd number divided by 2 is an okay, well, every odd number divided by 2 will have a remainder, I guess. If that makes sense. Okay, let's test out the program. Let's do 2. So it knows the number is even. Let's try just type in a few numbers.
Sorry, guys, it's just technical problems. But what Gavin was saying was,
Oh wait,
you
wait.
oh, okay, works
I
now.
can see I can wait, you can explain it. Sorry, I'm so sorry. I just
You're good. You're good.
okay. If you want to explain it, go for it.
I guess, yeah, I guess, okay, just a quick overview of what his program is, like a review. What he did was he's using user input, he typecasted it into an integer, and he's just checking if the number that's like that's inputted is even or odd. Say if you divide any even number by two, you're always gonna have a remainder of zero. If you divide any odd number by two, you're always gonna have a remainder of one. He obviously showed you on the screen right there, in those comments. So obviously he used an if statement. Uh, he used conditional statements um, to return certain statements for if it's even or odd in those
Yeah.
cases.
Yeah. So I don't know. Should we go through one more program or we have 5 minutes left of class?
You could maybe you could teach them we could cover
Yeah. I think next class we're gonna go through conditionals again because I know we like
yeah.
barely scratched the surface of them. Um, here, I think hmm, I know that like the homework doesn't have a ton of conditionals, so maybe we can yeah. But all right, let's just go through like one more program. We have 5 minutes left of class. It's probably gonna be our last thing. Okay, let's do like a grade calculator, like simple grade calculator. So we're gonna set a variable called score to no, let's take an input of a score. So score is gonna be equal to integer input, enter your score. Okay. And then what we're gonna do, if score is greater or equal to 90, grade equals A. If score greater equal to 80, grade equals B. If score greater equal to 70, grade equals C. Notice how we're setting the grade to the string. If score greater equals 60, grade equals D. Else, else grade is F. Okay, I didn't intentionally do it, but notice how like it's in a specific order in which it can't be like messed up by like this. Okay, if the other example that we had, so if like age was greater than 13, it can't be messed up like that because it's in a specific order where we compare down the list like this. Like 90, we compare if it's greater than 90, it's an A, greater than 80, B, C, D, E, F. Um, and let's just test this out, I guess. So if it's 20. Oh, I didn't print. Yeah, it's my bad. So let's print the grade. I covered this a bit last time, but I highly encourage you guys to use F strings. They're just a lot easier than normal strings because normally, if we were going to use just this, just string, we have to add the plus to add onto strings, and then we would do grade. But with F strings, what we can do is if we add an F, that creates an F string, grade, um, colon, and then we use curly brackets to indicate like the plus sign basically. And it's just grade. And it's literally the same thing as this, which is, or sorry, not that. And then plus, okay, it's being like weird, sorry. But yeah. Okay, like this. Sorry, that took so long. But yeah. So curly brackets are just like, or sorry, not curly brackets, F strings. It's an easier way to write the same thing. So if I scored a 13 on the test, I have an F, and I'll be very sad. But if I get a score of a 99, then I will have an A and be very happy. Okay, I guess that's kind of it for conditionals. I know like it might have been a little confusing, but don't be worried if you don't like really understand conditionals. I think we're gonna like go over it next class. Um, it's 4:30, so I think we're gonna call it for today. If you guys have any questions, like feel free to stay after class. But there is homework if you guys want to do it. Make sure to check the Google Classroom. There's a lot of resources there. Um,
Um yeah.
yeah. And yeah, if you have any questions, feel free. We're
Only
down to
three people did
stay.
the homework, so hopefully we get more people to do it. But
It's
yeah.
okay if you guys don't want to do the homework.